Hello, I've got time for one more screencast tonight, so let's go ahead and talk about solving ratios. This is going to be focused in on cross-multiplying and dividing, and I'll show you the other way that you can solve a equivalent ratio, just like we've been talking about in the other screencast. But unfortunately, not all ratios are going to be as easy as solving it through multiplying the top and the bottom by one number. So let's go ahead and just talk about that. In review, if you notice here, all of these ratios that you have in front of you have a part of the ratio missing, and that's what we're trying to solve. Writing an equivalent ratio, finding out what one part of that ratio is. So in the previous screencast, when we talked about finding equivalent ratios or solving, we talked about working in the direction of your variable. Okay? And in doing so, you want to start with what you know. So I know that I can go from 3 to 24. And by doing so, since I'm going from a smaller number to a bigger number, I know that I am multiplying. So if I go from 3 to 24, I have multiplied by 8. So if I multiplied the 8 by the bottom number, then I have to multiply by 8 in the top number. And when I do so, 1 times 8 is going to give me 8, which is what my n is going to equal. So in this case, n is going to equal 8. Okay, and a lot of the ratios are as simple as being able to just work from one side to the other. But as you can see, in this ratio here, it is not that simple. I cannot go directly from 40 to 16 without coming up with some sort of decimal number. So to do that, I'm going to do a very simple task of cross-multiplying and dividing. And so you're going to start from the top on each side and work diagonal to the other ratio. And I'm going to just draw some areas. So I start from the top left and move to the bottom right. And then I start from the top right and move to the bottom left. And what I'm going to do is I am going to bring down my equal sign, and I'm just going to multiply in a cross direction. So I have 25 times 16, and I just put it on the side where the arrow ends, or where it ends up on the bottom. And on this side I have n times 40. Okay, so I have those two equal to each other in a cross-multiplying manner. Now I'm just going to first simplify before I solve. In this case, on this side, I have to rearrange it in the proper format of 40 times n. And then I'm going to come up here and I'm going to do a little bit of workspace. And I am going to find out what 25 times 16 equals. I get 400. So it's already starting to clean up a little bit. And now, instead of n times 40 equals 25 times 16, we now have 40n equals 400. Now, solving for a variable, we are going to try to isolate the variable on one side. So that means we're going to have an n on one side and a number on the other. And to do that, we have to eliminate what is with the n. So remember, that says 40 times n. So to get rid of the 40, we have to do the opposite of what the operation says. If it says multiply, then that means we have to divide by 40. If we divide one side by 40, we have to divide the other side by 40. 40 divided by 40 is going to be 1, so we call that canceling out. We're left with an n. And 400 divided by 40 on this side is going to give us 10. So we said that n equals 10, and if we want to check that, we can just simply, where the n is, insert our 10 and see if we get 400. And in this case we do. So we know that the answer is n equals 10. Okay, let's do a couple more examples. Again, cross multiply and divide. Start at your top left, work down in a diagonal, start at your top right, and work down in a diagonal. bring your equal sign down, we have n times 5, or you could say 5 times n. And on the right side, we have 8 times 40. Let's clean it up a little bit. 5n equals 320. And this says 5 times n. So to isolate that n by itself, I have to do the opposite. I'm going to divide that side by 5. Since I divide that side by 5, I also have to divide my other side by 5. In this case, the 5's cancel out. Now, I'm not going to be able to work this one in my head, so I'm just going to take numerator divided by denominator. And bring down my 0. Okay, so in this case, n equals 64. You can plug the 64 in and try to reduce 64 over 40. If you get 8 over 5, you know that it's the correct answer. Or you can come back up to 5 times n, which is 64, and if that equals 320, then you know that you got the correct answer as well. It does equal that, but those are good ways that you can always check yourself. For the last one, top left diagonal, top right diagonal, and you're going to set them equal to each other. The left side, 13 times n, or n times 13. On the right side, 39 times 5, or 5 times 39. Clean this up a little bit, and you're left with 13n, and I'm going to use my workspace to multiply this larger number, and I get 195. So in this case, to isolate my n, I'm just going to divide both sides by 13 because it is 13 times n, and so that's the opposite. This cancels out, and I'm left with 195 divided by 13. If I divide this, I know that 13 can go into 19 one time, and 65, again, I'm going to use a little bit more of my workspace. 13, hold on one second, I want to give myself just a little bit more room. 13 times 4, I'm just kind of guessing where I want to start. I'm left with 52, so 13 times 5 is going to give me 65. Okay, so n equals 15. So I can check it one of two ways. I can say 13 times n equals 195, which means 13 times 15 equals 195, and in this case they equal each other. So I know that my answer of 15 is correct, or I can set up my original equations. If I do that, I get 5 over 13 equals 15 over 39. Okay, and then I would just reduce, and if I get the same thing, then I know that I'm right. Working in this direction, I divide by 3, and I get 5. And if I divide 39 by 3, I get 13. So I know that my answer of 15 is correct.